The processes in the mountain are fascinating because with the construction equipment developed by Marty and the tunnel boring machine, an entire tunnel factory runs through the mountain. The cutter heads on the 14-meter-high cutting wheel break rock fragments from the rock when they're rolling. The number and arrangement of the bits differ depending on the rock. Marty optimized them for the geology of Belkin. Through injection openings, stabilizing material can be placed in the rock directly behind the cutting wheel. With up to 2,000 tons of contact pressure, the entire machine pushes forward along the already built tunnel. The gap between the tunnel and rock is filled with a fast-curing mortar. The machine stops every 2 meters. Within the protection of its own shield, it builds a tunnel ring out of 7 segments. With the segment construction, the tunnel is secured by the first ring closure directly after the excavation. Because of the great risk of swelling of the rock, Marty builds an additional solid inner vault in the tunnel after the first excavation protection by using segments. In doing so, the supply and disposal of the tunnel boring machine must not be interrupted. The installation of the Renesco sealing membrane in the lower tunnel area is big. After sealing, the tunnel ground can be concreted. Because of the access to the tunnel boring machine, work is carried out under the drive-over bridge. The formwork for the concrete work hangs movable under the bridge. It is inserted into the area concreted the previous day. The formwork is extremely variable because the project requires walls with and without reinforcing iron and different wall thicknesses. The concrete is introduced by a concrete pump. Now the service gallery is extended to the bridge. The lateral gaps are filled with excavation material. Thus, the tunnel floor in the shell construction is done. The vault is now cleared for the expansion of the upper tunnel area. The tunnel ventilation runs via the service gallery and the ventilating air conduits suspended on the vault. The air conduit is periodically moved, shown here only schematically. The conveyor belt, which is also suspended from the tunnel vault, is deposited on the tunnel ground by the belt transfer truck in a flat curve, which does not impede the operation of the belt. Now the vault is free and can be strengthened. First, the reinforcing cages are moved. The reinforcing vehicle moves the cages with precision into position and affixes them with its swivel arms. All the locations for the subsequent work can be easily reached via the moving work platforms. The arched framework runs through the tunnel folded up. It is very mobile and can be retrofitted to different wall thicknesses. The elements of the head formwork are folded into gaps in the reinforcement and extruded as far as the segments. The elements are connected with sealing pieces and sealed against the segments with a compressed air hose. The concrete spreader runs in the formwork. The formwork is evenly filled via the mobile distribution station with swivel-type conveyor lines. The pressure of the liquid concrete does not shift the formwork. The concrete is concreted symmetrically on both sides. A comparison with the segments shows the tremendous strength of the inner vault. That is why thermal insulation prevents the massive concrete from cooling too quickly and cracking. Of the intermediate ceiling, the tunnel area in the shell is complete. With the tables of the intermediate ceiling, the vault formwork, the reinforcing, the hot melt and the conveyor belt vehicle and the bridge, Marty has created a complex choreography of special equipment which enables the tunnel to be built directly behind the tunnel boring machine.